Welcome back, everyone. This is the second lesson in the equations and formulas lesson group. And this one is called Solving Equations Part 2 with multiple variables. So it will be the same variable, but you will see it more than one time. We are on page 4. There we go. Page 4, okay, of your notes, and I'm going to go through these examples today. All right, so this part is not on your page, but just a couple questions that you should have in the back of your mind while you're working on this unit. So what should your thought process be when solving an equation? You should be thinking about, when you're solving an equation, what is it that I have to do, right? What is the goal? And it's to isolate the variable, right? It's to have the letter on one side of the equal sign by itself equal to a number. And how do I do this? How do I isolate the variable? You're going to do that by doing the opposite operations. All right, so on the lesson from part 1, all the examples only had one letter. Notice here you've got the letter A, but it's in 2 different places. But the goal is still the same. It is to have A equals some kind of a number at the end. So we're finding the root, which is also finding the solution, right? What is this A equal to? The sides have to be balanced, which means the left-hand side, which is 8 multiplied by something, has to be equal to 14 plus 2 times something. And we're looking for that answer for A. All right, so during the last lesson, I taught you that you want to have the letters on the same side. So we want the A's on the left-hand side. We have positive 2A on the right. The way we move it over to the left is we do the opposite operation. So if we're adding 2A, we're going to subtract 2A from both sides. That will eliminate it on the right-hand side because we have positive 2A, subtract 2A is 0. So they will be eliminated from the right-hand side. On the left-hand side, we have 8A, subtract 2A, which is 6A. And then on the right, we have our 14. Okay, now we have 6 multiplied by something is equal to 14. The opposite of multiplying is dividing, so I'm going to divide both sides by 6A. Sorry, by 6, not by 6A. By 6. 6 divided by 6 is 1, so we have A on the left-hand side, and then 14 divided by 6, we can simplify. Okay, reduce, divide the top and bottom by 2, which gives you 7 over 3. So 7 over 3 is the answer. Okay, that makes this equation true. If we wanted to check, we could sub that 7 over 3 back in for this A here and for that A over here, and then multiply. So 8 times 7 over 3, and then over here we would do 2 times 7 over 3 and then add 14, and you would see that the answers are going to be equal. All right, second example B, 9 times something minus 3 is equal to 6 times something. All right, so the first thing I'm going to do is I'm going to move the 3 over to the right-hand side, okay, so that the 9x is by itself. Okay, so now the 3 is eliminated on the left-hand side. It's been moved over to the right. Okay, which gives us 9x equals 6x plus 3. Now I want to move this 6x from the right-hand side over to the left, and I'm going to do that by subtracting 6 because it is positive on this side. Okay, so now on the right-hand side, they're eliminated, and we're left with the 3 on the right, and on the left, it's 9x minus 6x, which is 3x. So we have 3x is equal to 3, and now I'm going to divide both sides by 3 to eliminate the 3, which is multiplied by the x. Okay, which gives me x equals 1. And you can check that as well. 9 times 1 is 9, subtract 3 is 6. And then on the right-hand side, 6 times 1 is 6. So they are equal to each other. Okay, question C. Okay, same process, except what we want to do first is you always want to check to see if you can collect like terms, all right, before you start moving terms around. So on the left-hand side, I can see that I can add the 6 and the 8. Okay, and then on the right hand side, I can add the 8x and the negative 4x, and I can add the 7 and 5 together to simplify. Okay, so I have done that. 8 plus 6 is 14. Subtract 6x, and on the right hand side, 8x minus 4x is 4x, and 7 plus 5 is 12. Okay, so I've simplified, which makes the expression a little bit smaller, easier to deal with. All right, so what I've done here now is I've color coordinated them because I'm going to show you how to solve for x a little bit different than what we've been doing. So you can see that we have 4 terms here, and each term has a sign in front of it. So the 14x would have a little plus, okay, it's positive. The 6x has a negative, the 4x is positive, and the 12 is also positive. All right, so if I move a term from one side of the equal sign to the other, that sign has to move with it. And so what I'm going to do is I'm going to rearrange these terms, put them on the correct side of the equal sign where I want them. So what I want is I want the x's all on the left-hand side because we want our answer to be x equals something. And any constants I want to have on the right-hand side of the equal sign. Now, whenever I move a term from one side of the equal sign to the next, the sign is going to change. Okay, so on the left-hand side, I have a negative 6x. That can stay where it is. That's on the correct side. I want to move this 4x over to the other side. And it is positive on the right-hand side. What I want to do is change the sign to negative for the 4x because I am going to move it over to the left. Okay, it's kind of the same idea with what we did with the other questions. If I wanted to eliminate this 4x, I would be subtracting 4x from both sides, right? I'm doing the opposite sign. So another way of looking at it is moving that sign over to the other, or moving that term over to the other side and changing its sign. Now for the coefficients or for the constants, I have a 12 on the right and I have a 14 on the left, okay, side of the equal sign. It is positive here. And so once I move that 14 over to the right, it's going to become negative. Okay, so these are the two terms that I'm moving. All right, so negative 6x stayed there. The 4x moved over, so it became negative. The 12 stayed positive on the right, and the 14 moved over to the right, and it became negative. All right, now I'm going to collect like terms again. So negative 6 subtract 4 is negative 10x, and then 12 subtract 14 is negative 2. All right, now I'm going to solve as usual. So I'm going to divide both sides by negative 10 because that is the number I want to get rid of in front of the x. Okay, so now I have negative 10 divided by negative 10, which is positive 1. Okay, positive 1x. And then on the right-hand side, we have 2 over 10, which we can simplify to 1 over 5. Okay, divide the top and bottom by negative 2 to give you positive 1 over 5. All right, this example has brackets, okay, and there are some rules. So you're adding these to your handout sheet that you printed off. The first rule is you want to use a distributive property to remove brackets. Okay, and hopefully you remember the distributive property, right? It means if there's a number in front of a bracket, that number gets multiplied by everything inside the bracket. So the 3 gets multiplied by the x, and the 3 also gets multiplied by the negative 9. So that is the first step, is to get rid of those brackets by using the distributive property. So I've done that. 3 times x is 3x. 3 times negative 9 is negative 27. All right, combine any like terms. We don't have any like terms here that we can combine. When I say combine like terms, I mean on the same side of the equal sign, right? There's nothing we can combine here. Group all variable terms on the left and the constant terms on the right. So we have a variable 3x, which is on the left. That's great. That can stay there. The negative 27 needs to move to the other side. Right? It is negative on the left-hand side. I'm going to move it over to the right, and I'm going to change that sign to a positive on the right-hand side. Okay, so we have 6 plus 27, which gives us 33. And now we're going to do same thing we did the last question. We need to eliminate that 3 in front of the x. It's being multiplied. The opposite is division. So I'm going to divide both sides by 3. And on the left I have x, and on the right 33 divided by 3 is 11. There we go. So you might find this idea easier if you just think of it as, moving a term from one side of the equal sign to the other and just changing the sign. Okay, one more example. This is the last one. All right, so first step said to do the distributive law to get rid of the bracket. So I'm going to multiply everything in front of that bracket. So that 4 is going to multiply everything inside the bracket. Okay, so 4 times 2x is 8x, and 4 times negative 14 is negative 56. Second step, rearrange or collect like terms if you can. We don't have any terms to add or subtract here. The next step was to move the terms to the correct location, right? You want to have all the terms with the variable on the left, and then all the constants on the right. Okay, so 8x can stay. This negative 56 must move to the right hand side, and it's going to become positive because it is negative over here. Okay, so we have 8x equals 34 plus 56, which is going to give me 90, and now divide both sides by 8. Okay, which is 45, which is 90 over 8, but then I divided the top and bottom by 2 to reduce, so I have 45 over 4. All right, so those are your examples for today. For today's homework, if you could take a look at Unit 3, Lesson 2, page 3. So Unit 3 is the booklet that you have right now that you've printed off, and this is your homework booklet. So the homework for that would be on page 3. So give these questions a try, making sure that you are showing your work, and then check down here to see if your answers are correct. You do have a copy of all the homework questions and all the lesson questions for the whole unit. So if you feel like working ahead, you can certainly go ahead and do that. All right, good luck with your work. And yeah, send me an email if you have any questions. Talk to you soon, guys.